In a major coastal city, a new bridge stands as a testament to modern engineering. Well, its sleek arches span a wide channel, connecting communities and easing the flow of daily commerce. When the project was first announced, officials presented a clear and confident figure: a budget of $2 billion. This number was presented to the public through detailed reports and press conferences, outlining the economic benefits and the prudent financial planning behind the structure. The bridge promised to reduce commute times, support local trade, become an iconic landmark for the region, all within this carefully calculated financial framework. The figure was the anchor for public debate and the basis for its eventual approval. Years later, as the final sections of the bridge were put into place, a different number emerged. The total cost to complete the project had risen to $4 billion, exactly double the initial estimate. This final figure was not announced with the same fanfare as the first. Instead, it was revealed through a series of quiet budgetary reports and audits, long after construction was too far along to be halted. The new bridge was celebrated for its design and utility, yet it also became a symbol of a common and perplexing problem. How could a project planned by experts, approved by oversight bodies, and built by experienced contractors miss its financial target so dramatically and by such a predictable margin? This discrepancy is not an isolated incident. Around the world, from high-speed rail lines to new airports and energy infrastructure, public projects frequently cost far more than their initial budgets. The pattern is so consistent that it challenges the very idea of a budget as a reliable forecast. These are not small errors of calculation. They represent systemic failures in how we plan, approve, and execute the essential infrastructure that underpins modern society. The story of the bridge and its two conflicting price tags raises a fundamental question. Why do the initial cost estimates for major public works so often prove to be profoundly wrong, and what unseen systems are at play? The system for creating public infrastructure begins with a cast of distinct participants, each with a specific role. At the center are government planners, public agencies. They identify public needs, for example, a new transit line or a water treatment facility. They initiate the process, conducting preliminary studies defining project goals. Working alongside them are specialized consultants providing expertise in engineering, environmental science, economics. They assess project viability and develop initial designs and cost models. They bring knowledge public agencies may lack. Once projects gain support, the circle of participants expands. Private contractors, construction firms enter. They will build the infrastructure. They enter during procurement, bidding to win the contract. Financiers are also critical: public treasuries, private banks, investment funds. They provide the capital for multi-year, multi-billion-dollar projects. They focus on financial risk and return, which shapes how projects are structured and approved. The flow of money is a central artery. Overseeing the process are auditors, regulators. They ensure procedures are followed, funds are spent appropriately, project complies with legal standards. Their role is verification and accountability. Finally are the voters, the general public. They are the ultimate funders and beneficiaries. Their support enables political approval. The procedure is a linear, stage-gated path. It starts with an idea or stated public need. Then a feasibility study evaluates practicality and benefits. If positive, it moves to detailed planning and design. There, the first official cost estimate is produced and presented. Next is procurement to select a contractor. Then construction begins, monitored through oversight until completion and handover. Each stage is a checkpoint for quality and cost control. To create a budget for a project that may not be completed for a decade, planners use several tools. They break the project into thousands of measurable components, like a cubic meter of concrete, to create a unit cost analysis. To counteract natural optimism, they use reference class forecasting, analyzing overruns from similar past projects to adjust estimates upward. They also add contingencies, money set aside for unforeseen events like geological surprises or material price spikes, and use risk registers to track and plan for potential problems. Together, these tools aim to produce a robust, evidence-based cost estimate. But this estimate must then navigate a complex approval pathway. It's reviewed internally by senior managers, then presented to political bodies like a city council or state legislature. The budget becomes central to public debate, where officials weigh benefits against the stated cost. The number must be low enough to be politically palatable, creating pressure on the initial figure. This pressure often amplifies optimism bias, the human tendency to underestimate time and money. Planners and politicians may downplay risks while overstating benefits, making a project more attractive and easier to approve. Another cause is technical uncertainty. Initial estimates are based on incomplete designs. As engineering progresses, new complexities emerge. This is compounded by scope creep, where stakeholders request new features, like an extra station on a rail line. Each change adds to the cumulative cost. These additions are often a predictable outcome of the approval process itself, which favors a simple, affordable project at the start, leaving the true, higher costs to be discovered later. The timeline for elected officials is often a 4-year election cycle, far shorter than the decade or more required for a major infrastructure project. This mismatch creates a strong incentive for politicians to favor projects with low initial budgets that can gain rapid approval. A low estimate becomes a strategic tool for political expediency, allowing incumbents to claim credit for starting a project, while deferring the full financial reckoning to a future administration. The system for selecting contractors also drives up costs. Most public projects are awarded through competitive bidding, where the contract goes to the lowest qualified bid. This creates a paradox known as the winner's curse. Contractors are pushed to bid the lowest amount they think will win, not what the project will actually cost. The winner is often the most optimistic, locked into a price with little room for error. A rational strategy is to underbid to win the work, with the intention of making up the difference later. Once construction is underway, the contractor's bargaining position improves dramatically. They scrutinize plans for ambiguities or omissions, and each discovery becomes the basis for a change order. Now, negotiating with a captive client, the contractor can charge much higher prices for this additional work. The sunk cost fallacy amplifies the problem. With millions spent, abandoning a half-finished project is unthinkable, deepening the agency's dependence on the incumbent contractor. This interaction between political incentives, procurement rules, and contractor strategy creates a self-reinforcing loop that makes cost overruns a deeply embedded, repeating feature of the system. The most immediate consequence of systemic cost overruns is immense fiscal strain on public treasuries. When a single project consumes double its anticipated budget, the additional funds must be sourced from somewhere. This often means money allocated for other vital public services is diverted. Planned upgrades to local roads are delayed or canceled. School repairs are delayed or canceled. Maintenance for existing water systems is delayed or canceled. The diversion of funds leads to a growing backlog of deferred maintenance. The existing stock of infrastructure is allowed to degrade. This creates a vicious cycle. Neglected maintenance accelerates asset decay. Rehabilitation or replacement costs rise sharply in the future. The continuous need for extra money erodes long-term financial planning. Public agencies are forced into reactive, crisis management mode. Uncertainty from one project's overrun cascades through the entire portfolio. Lost user benefits from project delays are another significant cost. When delivery is late due to budget disputes and renegotiations, the public is deprived longer. Commuters continue to sit in traffic. The system that produces cost overruns also systematically delays delivery of public value, compounding negative impact beyond balance sheet numbers. The system-wide effects of chronic cost overruns extend beyond direct government finances, rippling through the broader economy. One of the most significant impacts is on investor and business confidence. When the public sector demonstrates a persistent inability to deliver projects on time and on budget, it creates an environment of uncertainty. The perceived risk of doing business in a region increases, which can deter private investment, slow economic growth. However, when the project is massively delayed and its final form is subject to constant renegotiation, it can stall or alter these development plans. On an international level, a country's reputation for managing large-scale projects affects its global standing. Nations that consistently deliver complex infrastructure efficiently and transparently are seen as more competent and reliable partners on the world stage. Conversely, a track record of severe cost overruns and project failures can damage a nation's brand, projecting an image of inefficiency or poor governance. Finally, the normalization of cost overruns erodes public trust in government itself. When citizens repeatedly see official budgets treated as meaningless starting points, it fuels cynicism and the perception that public funds are being mismanaged. This damages the fundamental relationship between the state and its people. The system that produces inaccurate cost estimates does not just build expensive infrastructure. It slowly dismantles the social contract and the public's faith in the ability of its institutions to manage large, collective endeavors responsibly. In the final analysis, the persistent and predictable nature of cost overruns cannot be fully explained by surface causes alone. They are components within a much larger, more intricate system. The true reason initial budgets are so often wrong is that they are not designed to be right. They are not purely technical forecasts. Instead, the cost estimate is the outcome of a complex interplay between political needs, contractual strategies, cognitive biases. The system functionally requires a low initial number to set the process in motion. The predictable failure of the budget is a sign the system is working as evolved. Core insight: the final inflated cost is a feature, not an error. Initial estimate: tool for approval. Subsequent overrun: tool for execution. The structure is hidden but stable. It serves short-term interests of key participants. Politicians announce visible projects. Contractors secure steady, large-scale work. Costs are borne later, diffused across the tax base and years, rarely forcing fundamental incentive change. Critical tension: would stricter rules solve this? Enforcing fixed-price contracts and punishing underestimates? Fewer projects approved? Or would cost-hiding move to opaque forms, off-balance sheet financing, reduced quality and safety? The challenge is redesigning a system that depends on the wrong number. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.